Okay, so we're still on equations of a line. Equations of a line. And this time what we're doing is we're finding equations of a line from a graph. Alright, we're finding equations of a line from a graph. So again, Cornell notes, we're going to take our sheet of paper. We're going to fold it in half. Open it up. And it's going to be from a graph. Alright, so I'm going to go ahead and draw and make a graph. Okay, so we're just going to make a graph together. Alright, now as you're doing this, try and make it as accurate as possible. Let's go each line, each one of these lines is 2. So 2, 4, 6, 8. And that's 0, of course. So -2, -4, -6, -8. I guess -10. Doesn't matter. Alright. And then you want to make it the exact same on this other side as well, to the x. So just a rough approximation. That looks about the distance there. So try and make them equal as you possibly can. Alright, and then let's go up in twos as well. 2, 4, 6, 8, -2, -4, -6, -8. Alright, it's just going to be a rough approximation, so don't worry about getting it completely exactly right. Just make sure that your distances, they're pretty much the same. So like that distance is that distance. So it's an approximation. Alright, then what I want you to do is, let's take a ruler. Let's mark the point for, let's take it to 4. Let's mark the point 4, 0 right here. Put it like an X on it. And the point, let's do -0, -8 right here. Alright, then I just want to take a ruler and join. If you don't have a ruler, just do your best guess, as long as it goes through those 2 points. Alright, perfect. Doesn't have to be exact. Again, it's just a rough approximation so that we know how to get it from a graph. Alright, now here's the thing. Here's the key point. From a graph, you could actually still do it from 2 points, because you could find 2 points on the graph. In other words, here's a point, okay, where it crosses a line. Where it gets to, here's another point, like, oh, that's not quite -2. 6, look, this might be 6, 4. But again, just dependent. You just can find a corner where you can read the coordinates, and that's the coordinate. So for example, this would be 4, 0. And then this would be 0, -8. And those are 2 points. So you'd label x1, y1, x2, y2. And pretty much go through everything we just did when we were finding equations of a line from 2 points. However, there is a faster way of doing it, or just getting it from the graph without having to do all that. But if you're comfortable doing it the long way, that's fine. But there's a easier way of doing it. So from the graph, okay, this is the one we've been doing. There's actually another formula that says y equals mx plus b. You need to find the slope and the y-intercept. The y-intercept is where it crosses the y-axis. So this is your y-axis. This is your x-axis. All right, so from a graph, it's very, very simple. From a graph, you're going to, again, step 1 would still be find your slope. Find slope, which is m. All right, so I'm going to go ahead and find slope, which is m here. Now, from a graph, you could do the 2 points and then plug them in to the formula to give you what slope is. Or you could do what they call rise over run. Okay, so slope is rise over run. How high are you going to go up? How much are you going to run? So I'm going to rise 2, 4, 6, 8. Okay, so I'm rising 8, positive because I'm going up. And then I'm going to run, okay, run 2, 4. So I'm going to run 4. All right, again, it's just rise over run. Also, you always read a graph from left to right. So from left to right, you can see that this slope is doing what? is going up, so your slope is going to be positive. So you get a negative number, you know you've done something wrong. Go ahead and simplify it. 8 divided by 4 is going to give me 2. So my slope is 2. All right. Do not write this next part down. I just want to show you that you're going to get the exact one if you do it from 2 points. So if x, don't write this down. So m was y2 minus y1 over x2 minus x1. All right, I already labeled them. y2 is 8 minus y1, which is 0, over x2, which is 0, minus x1, which was 4. 8 minus 0. Did I do that right? y2 minus y1, 8 minus 0, and 0. Oh, this is 0, negative 8. All right, 0, negative 8. Because you go 0 and then you go 8 down. So y2 is negative 8. There we go. All right, so negative 8 minus 0 is equal to negative 8. 0 minus 4 is equal to negative 4. Negative 8 divided by negative 4 is 2. So you see how your slope is still 2? That's because you can still do it from 2 points. However, rise over run is a lot faster. So you just count how many you rise. If you're falling, obviously it's negative. If you're going left, it's also going to be negative. All right, so my slope is 2. So I found my slope. Step 2 is still going to ask which equation do I need? All right, so which equation do you need? Again, you could still use the one that we did before because we've got 2 points, but I want to show you how to use this other one. Y equals mx plus b. I have m, which is slope, and b, which is the y-intercept, which is just basically look at where the graph crosses the y-axis. So here's the graph. Here's the y-axis. It crosses the y-axis at negative 8. So my y-intercept, or b, is equal to negative 8. All right, so I need the graph y equals mx plus b. And plus b is going to be negative 8. So all we're going to do is plug in the number. So y equals m, which you remember we found out to be 2, x plus b, which is negative 8. All right, then go ahead and do just like the other one. Go ahead and just simplify. Y equals 2x. A positive and a negative are going to give you a negative 2. And you're done. That is a lot faster than plugging it into the other equation to find, using the 2 points to find y equals 2.